Let's get started with day 2 of SODACON2020, the open source event dedicated to advancing standards and technologies in data and storage. On your screens now, let me invite Mr. Stephen Tan, the SODA Board Chair, VP and CTO Cloud Solutions Future Way, for the opening keynote. Over to you, Stephen.
Hi everyone. Welcome to day 2 of SODACON. We had a great day 1 yesterday. There were a lot of like what Anviv was saying. There were a lot of interesting sessions. We had, I think the panel session hosted by Tathagat was great. We have the panelists from Intel, Microsoft, Huawei, and Sony. That was really a great session. And of course, the other keynote session after, whereby we presented the data and storage challenges use cases. We got the end users, Toyota, China Unicom, and what was that? China Unicom and Reliance Jio, as well as Huawei presenting all the different use cases from users. So that was great. And then, of course, we have the session whereby the SODA developers presented on the Greenland release of the Open Data Framework and provided updates and demos on that. And then we talk about we had the also the maintainers from the different projects. The DAOs project that just joined Intel. I mean the DAOs project from Intel that just joined SODA Foundation. The YIG project from China Unicom that also was that's also part of SODA Foundation. And then we also had the Scality people presenting their open source Zenko project, and as well as NetEase Curve distributed storage project. So today again we are gonna have we have a great lineup of speakers. So do stay tuned for all the different speakers. So let me move on to let me see. Okay, so yesterday in my keynote itself, we talked about how everything is about data, and we have all the data. I mean that's generated out from all the different sources that move to the edge. Go to AI, machine learning, IoT. Of course, is the source of the data. And also, it runs through big data, the cloud, and how 5G, can actually, enable the rapid transmission of data from the edge to the, from the edge devices to the edge data centers, and as well to the data center cores or the cloud. Okay, so today what we're going to be talking about is how all this data, again, how Open Data Framework, how the Open Data Framework is able to serve all the different needs of these different technologies, and the different other panelists or keynote speakers on this session, from NTT Communications, China Construction Bank, FinTech, from China Mobile, and as well from Huawei. I'm going to present all the different, the different use cases and how all these technologies come into place. Okay, so the Open Data Framework, it addresses, it unifies all the different solutions out there through standard data policies, and using machine learning and automation, we try to simplify or reduce human intervention. Okay, so the Open Data Framework, again, tries to address challenges and open source innovation. Okay, so this is a very good use case. This is a very good use case of the different technologies, or a showcase of the different technologies that are that come into use in the current real use case. So Toyota, Yazawa-san yesterday actually presented this connected car platform of Toyota. So today I'm putting into place how actually the SODA Open Data Framework can actually try to serve this connected car platform by connecting all the different pieces together. So according to the Automotive Edge Computing Consortium, a connected car can generate about 20 petabytes of data per month per vehicle. Okay, so assuming a data center or a car platform has to serve 3 million cars, that will mean a total of like 60 petabytes of data will be coming into the data center every month. So if you look at the car here, the connected car platform over here, you can see like the car itself. I mean, you have the IoT and then the 5G there, the 5G network that will come. I mean, that will be transmitting the data either from the car itself. I mean, the sensor data or the video from the camera feed itself. So it may come to the edge, or it may go to the data center. So if it comes in the edge or go to the data center, I mean, there may be things like doing analytics or some kind of AI or machine learning kind of applications running over there. So if it goes to the edge, data at the edge ultimately there may be data that may not be needed. So that may be filtered out. But a lot of the data that's at the edge actually needs to be moved to the core data center. Okay, so that's one of the key pieces of things that we need to do. And then for data, or if the data goes directly from the car to the data center itself, it goes to tier 1 storage. And over there, you may be doing, again, things like analytics or kind of machine learning kind of stuff. And ultimately, after data has been sitting in tier 1 storage for a while, as the data age, the usefulness of the data becomes less. So data may need to be moved to less expensive tier 2 storage. So this is kind of like what we call lifecycle management or tiering, whereby data has to be moved after, say, a period of once the data is reached an age of, let's say, 3 to 6 months, then you may want the data to be moved to tier 2. So this has to be done automatically. I mean, you cannot have like operators going there checking all the data and see which of the data that needs to be moved and so on. So all this has to be happening automatically, okay, or through some kind of data policies. So from there, data that sits in tier 2 storage, again, it may go through analytics and machine learning kind of stuff. And also it may be distributed to the cloud, whereby actually the cloud, over there may be other kinds of applications that need to be run that needs the data, okay, or data may be moved to the cloud for retention. Also, at the same time, tier 2 storage, again, after sitting in there for a while, once the data has been in there, say a year, then the data may need to be moved again to cold storage, whereby it gets archived for whatever the lifetime of the car, to maybe do for things like vehicle maintenance record and stuff like that. So again, data lifecycle management is actually pretty key in this platform itself. And also, when we move data from tier 2 storage to the cloud itself, there may be like multiple cloud service providers that needs to be connected. So there's also another piece of thing. So let's take a look at how the Open Data Framework serves all this function. So first of all, this is unfortunately not very responsive. Oh shit. Okay.
Even maybe you can ask Shit to move also if you want.
It's fine. Okay, so so first of all, for the block file and object storage, this is basically in any of the places. I mean, whether it's at the edge or in the data center or in the cloud. I mean, we need all these different types of object. I mean, all these different types of storage for different purposes. So SODA itself, the Open Data Framework actually provides the block file and object services provisioning services for that. And then there's also the multi-cloud piece that I was talking about. So SODA provides a single S3 interface to connect to all these different clouds. So you don't have to, create an interface for, say, AWS S3 and then Azure or Google Cloud services. I mean, you don't have to create. And then there may be like IBM Cloud that you have to work with, or Alibaba Cloud and so on. So having a single interface is kind of key to support multi-cloud kind of services. And then for backup and recovery, again, as I was mentioning earlier, data from the tier 1 or tier 2 storage needs to be backed up, and then it goes to the cloud or goes to the tape itself. And then in terms of lifecycle management, from the edge to the data center, and then from tier 1 to tier 2 storage, from tier 2 to the cloud, or tier 2 to the cold storage. And then also we need to provide have consistent security and compliance for data across from the edge, the data center and the cloud itself. And also for data that gets archived or moved to tape, if you look at the picture on the bottom right, actually the tape or the archive disk actually needs to be moved to some offsite warehouse. So how do you actually secure those kind of data? Because it's kind of important. If, let's say, if you back up everything to tape and that tape, get lost on the way because somebody robbed it, or the tape just get dropped off the truck itself, then the data is not secure. So how do you ensure that kind of security? So I mean, this open data framework can actually support, like encryption and then providing the keys to unlock the tape when it gets recovered. And then also there's retention and archive, the tier 2 to cold storage that I mentioned about, and the tier 2 to cloud for long-term retention. And lots of all the data integration. There's the data integration for analytics and AI and machine learning. I mean, this framework provides that kind of integration function. So what's important about this picture is that the open data framework actually helps this this platform or any kind of platform to actually enable multi-vendor solutions to be integrated seamlessly within this platform, and then having kind of a consistent data policies across the edge, the data center, and the cloud itself. Okay. So next, we actually have more interesting talks than mine, actually. So the following are the speakers from these different companies. China Construction Bank, FinTech. This is one of the largest bank in China, and actually, I think it's the top 10 in the world, actually. And then the NTT Communications, China Mobile, and Huawei. So without further delay, let me introduce the next speaker for this keynote session. The next speaker is from the China Construction Bank FinTech, Zhong Lai. He is the general manager of the cloud platform at the R&D department, and he'll be talking about their cloud database platform practice based on Kubernetes and SODA. So let's welcome Zhong Lai. Actually, you can pass the control to him. Yeah.
Shamlai, you can take the control now.
Okay. Hi, Steven. Can you hear me?
Yes, Shanlai, we can hear you.
Yes, we can.
Okay.
It's very clear.
Okay.
You want to take the control, or should I move the slides?
Please have me turn pages, please.
Yeah, so I have given you the control. You can take the control.
Okay. Greetings, everyone. This is Xin Lai from CCB FinTech. It's a great honor to be here in SODACON and share our practice about cloud native in CCB. Title of my presentation is CCB's Cloud Database Platform Practice based on Kubernetes and SODA. Next slide, please. Okay. Before anything technical happens, I'd like to give a brief introduction about China Construction Bank and CCB FinTech. China Construction Bank is a major commercial bank with leading position. CCB has branches in over 29 countries. It ranked number 2 in the list of top 1,000 world's bank 2020 published by the Bank magazine, and ranked 13th in Global Fortune 500. CCB FinTech is a fully funded subsidiary of CCB, which is the first fintech company held by Chinese nationalized major banks. There are development centers in 7 major cities of China with more than 6,300 employees. With edge techs like cloud computing, AI, blockchain, big data, and IoT, we established mature and systematic core tech abilities, contributing to CCB's digital transformation. Next slide, please. Okay. Next part will be an overview of our cloud native platform, as you can see from the image. In CCB, our infrastructure cloud is quite complicated. Besides private cloud based on VMware and the traditional data center, we also introduced a complete public cloud tech stack in our data center. We deployed our Kubernetes on Azure, underlay or overlay for different situations. We have traditional SAN and NAS storage as well as distributed storage. So when constructing a cloud native platform based on Kubernetes, it has to be able to meet all kinds of basic tech stack and support hybrid cloud, heterogeneous computing, and complicated storage environment. In order to share the difference of infrastructure, we introduced components like SODACON and for achieving cluster management of Kubernetes. We built a global controller plane beyond application clusters. Through global controller, the HA deployment model is realized. Above cloud native platform, we support the build of cloud database platform, AI platform, big data platform, and financial core application system. Along with this process, CCB is making progress in cloud native architecture transformation. Next slide, please. Okay. After taking an overall look, let's move on to the detailed architecture of cloud database platform. There are several key features like Class AZ deployment, heterogeneous storage, and stable database cloud service in order to fulfill the request of Allen zone isolation. Our database clusters instances are distributed in different Kubernetes clusters. Global operators are used to control error healing and automated operation and maintenance. We also developed a more stable deployment model named stable model. Besides packing storage and config, it also includes high performance straightforward network based on SR-IOV, IP claim, and network operator, which stables network structure. For supporting heterogeneous storage, we introduced SODA to support both SAN and distributed block storage to fulfill different business situations. Next slide, please. With innovation in technology and management methods, we achieved some targets. On our self-developed cloud database platform based on Kubernetes, we delivered over 600 database clusters for CCB's business application in 1 year. Users can deploy a HA database cluster on our own within 1 minute, which promotes the efficiency of applications landing. In the same time, we established multi-level data protection measures, ensure data security at extreme situations. Of course, one of the basic requests of cloud database is free from maintenance. With the high request of SLA in financial industry, we put a great effort in breakdown, healing, and isolation. For example, we restricted the automation within database management unit and prevent the spread of malfunction from logical control plane. Our aim is to ensure security and stability while enjoying the efficiency and cost reduction from automation. Next slide, please. Okay. As a cloud database platform, storage is always one of the most important issues to think of. SODA, with its great practice in data storage, is something we can refer to. As we know, there are storage devices of various models and from different vendors. Different backend storage and protocols brings challenges for developing storage plugin. In order to fully utilize storage resources, we need to keep building plugins for every kind of storage. And as more plugins are used, pod number considered with CSI in Kubernetes are increasing. Managing and maintaining different storages are getting harder. It's at this moment when we happily found out about SODA, a project devoted for uniting storage management. DOC and MVP, which are the core projects of its foundation, are very helpful for our situation. As the monitoring of SODA getting perfected, it could promote our level of automated maintenance. Next page, please. Okay. Under the cases of banks, multi-data center, it is a critical requirement for container cloud platform to do cross-cluster management. Not only application deployment needs to cancel Allen zone as a solution. Data requires multiple storage and cross-cluster flow. Requirements for key data backup are higher as well. In the future, we hope to achieve cross-device, cross-data center, storage migration, and backup of business data, and manage our storage through unified console, hence increase data security. In the meantime, we are also looking forward to SODA features of monitoring and alerting. It could get monitoring data from basic storage device so that cloud platform could do better management and more automated maintenance. Next slide, please. Okay, finally, CCB Fintech, as member of SODA Foundation, we are very glad to see its breakthroughs in multi-cloud environments and heterogeneous storage management. We will work with SODA to solve the container storage management challenges in cloud-native situations. Hope to see more peers of financing industry to join SODA and join us to improve the innovation and the development of open source technology in the global financial area. Okay, that will be all for my presentation. Thank you very much for listening.
Stephen, you're on mute.
Okay. Thank you very much, John Lai. We certainly, I mean, hope to bring more financial companies around the world to, collaborate together, to have this, yeah. So next, I'd like to invite Kei Kusunoki from NTT Communications Japan to join us. He is the chairman. He's actually one of the SODA board members and the SODA TOC co-chair. And of course, he's a storage architect at NTT Communications. And he'll be talking about the service provider. NTT Communications is a service provider, the use case and its prospects. Okay. Okay, please.
Oops. Okay. Can you hear me?
Yes, Kay. Yes, you're audible.
Due to my iPad, I cannot control the slide. So could you control that? Could you go back to the top slide?
Can you go back to the first slide, please, Ashit?
Yeah.
Yeah. Okay. I can control it for you.
Yeah. Thank you.
I can move.
So thank you. Could you go back to the title slide? Sorry. Okay. Thank you. So hi everyone. And thank you so much for introduction me, Stephen. I'm Kay. So today I'd like to talk about a service provider use case and prospects for future. So so could you go back to could you go to next slide, please? Okay. So first of all, so please let me introduce my group company briefly, very briefly. So NTT is a Japanese telecom carrier group. So our group have many networking company. So mobile network or regional network. And my company, NTT Communication, is working on global network and data center or cloud. So could you go to next slide, please? And let me explain more. So our infrastructure business domain are basically a global network, data center, and cloud services. So as a global network, we are offering inter-cloud DC network and the closed network between customers on-premise and our data center. So our data center capability is global scale. So we have many data centers in the world. And also on our data center, we are offering private and public cloud service. So this cloud service is basically a VMware-based IaaS and OpenStack-based IaaS. So could you go to next slide, please? So on these cloud services, we are providing many solutions and application as a smart data platform. So this is our platform design overview. So we are offering many, as you can see, AI service or Salesforce or SAP service or data management or data analytic AI service or IoT service. So using our infrastructure, it means cloud and network. We are providing many solutions and application for our customer. So could you go to next slide? Okay, thank you. So and in this platform, we are facing some problem in terms of the storage orchestration. So on our cloud, it's VMware and OpenStack. So we need to connect to storage, of course. So each orchestrator, VMware and OpenStack, need to talk with our storage infrastructure. But each vendor have separate original API, and to deal with that, we developed the original storage controller from scratch. So that development cost is really high for us. So modern storage have many updates to catch up with Kubernetes or OpenStack or VMware. So every semester we need to update that in terms of the integration with VMware or OpenStack or Kubernetes. So such kind of reinventing wheel is really hard for us. So, and also our VMware environment need to talk with directly network. So this is direct access in our management plan. So, but for customer cannot use this native API from storage because we need to build storage usage for customer. So customer need to use our original controller API, but that is not compatible with customer's API. It's not open source. It's original API. So customer cannot leverage their application open source software using open API. So it's a most prime example of this is Kubernetes. So that is pain point for the storage orchestration. So could you go to next slide, please? So if we can use SODA, through SODA, so all our IaaS environment, VMware, OpenStack, use SODA, and also customer can use SODA. That is simple, and we don't need to develop the controllers from scratch. And in terms of the data management, single data management point is really easy for everybody. And open source API is really helpful for also customer. So that is our use case. So could you go to the next slide, please? So for some reason, there are some image is corrupted, but yeah, please imagine that. So this is our IoT factory use case. So in smart factory use solution, there are so many IoT devices in the factory. So camera, monitoring camera, or many humidity sensor, temperature sensor, or something like that. So, and using these devices, we are offering human vision AI or video recognition AI or voice recognition AI and monitoring production output or operational tasks and so on. So could you go to next slide, please? So through SODA, such kind of IoT smart factory can use SODA, and in combination with Kubernetes. Yeah, that is good use case we are thinking. And could you go to next slide, please? And finally, I'd like to talk about our activity of this year. So we executed POC about VMware and NetApp because we are using that in these appliances in our environment. So we evaluated VMware vCenter integration and basic cloud operation on network driver. So result is basically it's okay. We can see some fundamental operation, but other feature didn't work. So like delete snapshot or making another snapshot or something like that. Could you go to could you go back? Okay, yeah. Oh, oops. Could you go? Oh, could you go back to current slide? It's too back. Oh, that's one. That's one. Yeah. So, and we discussed the several cold storage use case and object storage use case in Japan community. We are keep on continuing it. Yeah. So could you go to next slide, please? And some prospects. So as we face some problem with our POC, so we are hoping more development in storage driver development. So we wanna see more storage vendor and also more development for current drivers. So so in terms of the service provider use case, so that need to more reliability or HCA feature or authentication or several aspects, so that need to have, we think. So and also object storage use case is important for us. So considering IoT use case. So we are talking about that in the community. So we are keep on talking with that. So could you go to next slide? Yeah, that's all from me. So thank you for listening.
Thank you, Kay.
Yeah.
Yeah, that's good. So our next speaker is Dan Jin. He's the storage service architect from China Mobile, and he'll be introducing the China Mobile cloud storage and its requirements in multi-cloud management. So Dan Jin, please.
Yes. Okay. Thank you, Steven. And hello, everyone. Can you hear me?
Yes. You're welcome.
Okay. I'm Dan Jin from China Mobile, and today my topic has two main parts. The first one is the introduction about the present situation of our cloud storage service. And after that, we can see the current situation and the challenges we faced in our platform, and leads us to search for a suitable way to meet the requirements on multi-cloud data management and data autonomy. And we think SODA will be the best solution, highly standard and flexible way to achieve our goals. And please shift to the next page. Hello. Okay. Oh yeah. Yes. I'll do a brief introduction about China Mobile and our cloud platform, which named BIGCLOUD. And as the world's largest telecommunication service provider, we have over 900 million customers. Plus the huge amount of our base stations, these will be a leading advantages in the area of 5G and edge computing. And with the help of our huge customer base and the infrastructure foundation, it's quite natural for BIGCLOUD to achieve up to 700,000 enterprise customers since our public cloud service released at 2015. Please shift to the next. Okay, according to our infrastructure investment principle, we divide regions into 3 different levels that they are central, divisional, and marginal. And the BIGCLOUD now can offer 25 regions across China mainland. The provisional coverage rate exceeds 80%, and we are still improving on that. Besides the public cloud service, we also provide dedicated cloud service in more than 12 provinces. The key point is that lots of our customers spread over these provinces, which use our dedicated cloud, have the needs to share their data with each other. And we need a mechanism to support the data exchange across between the public cloud and the dedicated cloud data centers. And that's a situation at which SODA can distinguish itself. What's more, no matter the data flows inside the data center or between multi-clouds, we evaluate the data safety as the most important thing. So BIGCLOUD have been verified and certificated by the dedicated organizations and authorities, such as Trusted Cloud by CAICT, CSA, DJCP, and so on. We consider BIGCLOUD as a trustable and reliable cloud service provider. The solutions which SODA provides on data protection will enrich our architectural toolbox. Please shift to the next. Okay, BIGCLOUD had a very classical architecture with 4 levels. The BC Cube and BC Mental as our hardware environment. These 2 products are highly customized both for our service and the performance requirements. On top of that, we build our IaaS infrastructure, which including visualization, software-defined storage, and network service. The most upper layer are PaaS and SaaS service. With this layering architecture, we provide the same solutions for our public, private, and hybrid cloud service. Next slide, please. Okay. During the management of our cloud products over these years, we faced a lot of technical and architectural challenges, especially on the scalability problem. Be specific, in the object storage, we face 2 main problems. The first one is the object counts, and the storage size inside one bucket was limited by one storage cluster. And the data rebalance has great impact for foreground service experience. And we think the simplest way to solve this problem is to expand the service across multiple clusters by adding an access layer, which handles the route to these clusters. After that, we can now achieve over 100 petabytes storage capacity and over 100 billions of objects in one bucket. The problem here we face was that as the service expands and ages, the hardware environment and the software architecture between different clusters will show the heterogeneity among them, which will be the obstacle for service upgrading and the data migration. Again, we think the NBP framework which SODA provides will elevate our operational pain a lot. Next slide, please. Okay, in the block and file storage service, we faced the scalability problem too. Besides that, the performance requirement was more stringent. Due to the limited time, I won't talk too much today. In our old architecture, we use Ceph as the main storage solution, but we find that the very long I/O paths in the Ceph architecture hurts the performance. Lots of synchronization not only complicated the software development management, but also made performance tuning very difficult. We built our new solutions based on 2 main trends on storage technology. The first one is that storage bottleneck moves to software from hardware. So the user space I/O design fits the new trend. Techniques such as SPTK and RDMA play an important role in these days in storage service. And another important point is that the decentralization design was hard to management and was vulnerable to scalability problem. Our new architecture is based on centralized metadata design, and we can achieve very flexible I/O schedule capability, and I/O failure can be handled more graceful, and the data durability will be higher. Next slide, please. Okay. Another problem we faced was the data lifecycle management. As we see, the EBS and EC customers typically store very critical data within these services. They need a safety and efficient way to keep their data to meet data fault tolerance and regulatory requirements. Backup data to affiliate independent third-party service or another cloud platform is a good solution. And for the object storage, data can be labeled into different groups based on the access popularity. Different groups can benefit from these specific storage and access pattern and achieve more efficient way to organize their data. And we think SODA will play an important role in these two areas. We hope to use SODA to leverage our data management ability across different products or even different clouds. And we think that's valuable for both our customers and our goal to achieve flexible data management strategy. Yes, the next slides. Okay, finally, we are confident that China Mobile has the ability to embrace with community and give the feedback to open source community. As we can see, we are the top contributor in lots of open source projects such as Safe OpenStack and Kubernetes. We are highly expect to see our cooperation on SODA community. And thanks for your patient listening. That's all my slides.
Thank you, Jingden. Certainly welcome China Mobile to join SODA Foundation. Okay. Next, we have.
Okay. Hello, everyone.
Hi. Next, we have.
Can you hear me? Yeah.
Yeah. Hi. Next, we have Mr. Wang Youshen. He's the director of open source developer department in Huawei. He'll be sharing with us the challenges and coordination on data management of industrial internet era. Youshen, go ahead. Thank you.
Okay. Thank you very much, everyone. I'm very happy to share my topic with everyone. Just as Stevens introduced, my topic is on challenge and coordination data management of the industrial era. So next slides. Hello. Yeah. So I listen that first for the international industrial internet eras. We know there's 100 billion IoT equipment where a connected network. It means that different kind of original and formal that were created at every moment, and also means that a lot of historical data need parallel at the same time. So how to assure that all these data can be can be searched out timely with high efficiency is a key challenge. And also at the same time, we do think that all these data will be deal with parallelly. It means that for the Azure, for the network, and for the data center, we need to assure that can be parallelly handling. So it means that we need to have the innovative data distributed and scalable to support the kind of the challenge. And also we know every day it means different kind of the new application we create, and together it means a lot of new data need to be can cancel with different kind of the mass methodology, and also maybe we have no the natural mass learning. Maybe we need AI and also new leading technology to support the handling of all this data. So I do think that for this arrow, it means we need to redesign the data management. It means that re-architecture of the whole solution. Okay, next slide. Yeah, I do think that for every industrial, including a previous presenter, including CCB and China NTT and China Mobile, introduced that we have a lot of the requirement to assure that we have the solution to deal with kind of the challenge of the this kind of the digitalization of the every industry. In Huawei's position, we do think that it means that the whole ecosystem need to cooperate to innovate to confront with intelligence. So I do think that the open source is very good. Is the best way to confront with challenges. So it's very clearly the key contribution of the leading open source foundation, and also we create a lot of the new open source projects such as Kubernetes, and it support the application can be transferred from that to the Azure easily, and also the Kubernetes is increase efficiency to such that according to need in the human volume of the data, and also we have the open ROCN and open Gauss to certify the big data and database requirement. And also I do think that everyone having already introduced SODA can support a lot of challenge we have confront with in different scenarios. So I would like to introduce two typical scenarios for the financial and telecom scenarios to try to understand the challenges we are confronted with. Okay, so next slides. Yeah, first I do think that for the telecom arrows, everyone knows that maybe we there's a very broadened and complex network from the terminal and to Azure to network to data center and to with hybrid cloud. And I do think that different that will be created and different form where that will be created. So how to assure that all this that can be transferred and can be interwork together, and also we need a kind of the API, and also to support this data can be interwork together. I do think that everyone it's easy to understand it that there's a lot of challenge for this scenario, and it means that all this data maybe maybe need handled in different layer, and also all this data need to be handled together and maybe coordinated together. So I do think that that's a lot of very high level challenge for this scenario. Okay, next slide. Another scenario is a bank financial data center. It means that a very high volumes data and with a lot of heuristic touch need to be dealt with. So I do think that also there's a lot of challenges to confront with. It means we need a management to the heterogeneous storage and resources, and with low storage utilization and high volume resource waste, and addition that also we get a lot of difficulty to confront with prediction analysis of the capability and fault. So anyway, I think that how to resolve all these issues. Next slide. Yeah, we have defined structure to resolve all these challenges. I think the SODA is a very important part, together with different kind of the open source project, including I have introduced including CUBERNETES and also KUBERNETES, and together with industry's leading projects such as of Python and Cafe and also Manspo together to concrete the kind of the solution satisfied with different scenarios requirement, and to assure that we can compete with all these leading vendor solution, including IT and CT and Aeros vendors together, create a very flexible and open solution to support the customers' requirement to promote the process of the digitalization. Anyway, I do think that we have already see a lot of the successful case, just as what we see this partner introduced previously, including CCB and also NTT and China Mobile, and also we know that a lot of the new case we have already working on. Anyway, I do believe that it's a great we can get more opportunity work together to promote the process of the digitalization of the of every industries. Okay, it's my sharing with everyone. Okay, thank you, Steven, and everyone.
Thank you, Yusheng Wang. Steven had to drop off. He couldn't connect, so I'm going to be taking over from here. Thank you so much to all our esteemed keynote deliveries. Thank you, Kei-san. Thank you, Ding Deng. Thank you, Sean Lai, and thank you very much, Yusheng Wang. I like the last statement in your slide: collaboration, innovation, and success. Definitely, we are looking to do that here at SODA Foundation. Looking for innovation, and with collaboration with all of you, we definitely are looking at success. Thank you so much.
Okay.
All right then.
Okay, sure. I do believe. Okay, thank you.
Thank you very much. Yeah, thank you. I believe we are already over time, so I'm just going to go on to the next session, and then we'll take some questions towards the end.